synthetic division, okay? So synthetic division was created when someone was like, you know what? I recognize a pattern with long division when you're dividing by linear divisors. So it only works when your divisor is linear. By linear, we mean that it's in the format of mx plus b, right? Your x can't be squared, your x can't be cubed, it can't be any other power but 1, okay? So if it's in mx plus b, what do? Well, you set this equal to 0, and then you proceed with this process, okay? So what synthetic division does is it eliminates your variables. So all you're focused on is your coefficients and your constants, okay? And so you write out the coefficients of the dividend, and then you're going to put the 0 of your divisor. So the 0 of my divisor goes on the outside, and then you divide. So this problem originally was 3x cubed plus 4x squared minus 3x plus 2 divided by x minus 2. That's where this problem started off as. Okay, so from there, we wrote out its coefficients and constants, 3, 4, -3, and 2. Do you see 3, 4, -3, and 2? We then set its divisor equal to 0. And if I set this equal to 0, it's going to give me 2. Does that make sense? All right, now, to get it started, you're going to bring down your leading coefficient. Just like normal, we would divide with our first term, right? We bring it down. This is the trick. When you diagonally, we multiply, we write its product. So diagonally, we multiply, then diagonally, we write its product. Does that make sense? So here we have 2 times 3 is 6. Vertically, you're going to add. 4 plus 6 is 10. And then you repeat the process again, okay? So diagonally, we're going to multiply and write its product. So 2 times 10 is 20. So we multiplied and wrote its product. Vertically, we're going to add. -3 plus 20 is 17. Now we do it again. 2 times 17 is 34. And 2 plus 34 is 36. Okay? Just like when we divide, we're going down a term, right? We were going down a degree. So this started off as a 3rd degree. It's going to end as a 2nd degree. So our answer is the numbers here are your coefficients of your quotient. So this is 3x squared plus 10x plus 17. And you have a remainder of 16. 36. I don't know where I saw 16x. Okay, are we ready to do a full one? Okay. Got an email when I got it. All right, so I want you guys, we're going to set it up, and then I want you to try. So the first thing we're going to do is we're going to take our divisor, set it equal to 0, and find our 0. So x plus 1 equal to 0 means x equals -1, right? So that means -1's on the outside. And then our coefficients here are 2, -4, and what am I missing? An x, so I have to put a 0. All right, I want you to try. We will get our engines going by bringing down our 2. Now remember, diagonally we multiply and write its product. Then vertically we add. Diagonally we multiply and write its product. Vertically we add. Okay, and go. Okay, so we brought down, diagonally we multiply and write its product. So -1 times 2 is -2. Vertically we add, so we get -6. Repeat, -1 times -6 is 6. 0 plus 6 is -1 times 6 is. And -1 and -6 makes -7. This is my remainder. Okay, so this means I went from a 3rd degree. Now I'm going to go down to a 2nd degree. So my solution is 2x squared minus 6x plus 6. minus 7 over x plus 1. Okay, depending on the problem, it may ask you to write it in full form or it just may ask you what is your remainder. Okay, so remember, it's always 1 degree less because we divided something out, right? We factored something out. All right, okay. If y'all have no questions, today's exit ticket is here. So take out a paper, write it down. You're gonna turn it in. Probably only need a half sheet of paper if you want to split a paper with somebody, but you're gonna turn it in, so. All right, that's all I have for 4.3 today. We'll be doing 4.4 tomorrow. Yeah, you're gonna turn your ticket in the box. Look at your notes. Can't work with your peers. Just your notes. Just the exit ticket.